Section 1. The Digital Age's Guardians, Hash Functions. The internet has revolutionized our lives. We connect, communicate, and share information at an unprecedented scale. This interconnected world relies on trust. Trust that our data is accurate, our communications are secure, and our identities are protected. This is where hash functions come in. Hash functions are the unsung heroes of network security. They are mathematical algorithms that transform any piece of data into a unique, fixed-size string of characters, called a hash value. The beauty of hash functions lies in their one-way nature. It's easy to generate a hash from an input, but virtually impossible to reverse the process and obtain the original data from the hash. Imagine sending an important document online. How can you be sure it hasn't been tampered with? Hash functions provide a solution. Before sending the document, you create a hash of it. The recipient then generates a hash of the received document. If the two hashes match, it confirms that the document arrived unchanged. Let's delve deeper into the world of hash functions and explore their crucial role in safeguarding our digital lives. Section 2. Unmasking hash functions. A look under the hood. Hash functions might seem complex, but their principle is simple. Imagine a magic box. You can put anything into this box: a document, an image, a whole movie. The box processes the input and spits out a unique code, the hash value. This code always has the same length, regardless of the input size. This magic box is a one-way street. You can easily get a code from an input, but you can't reverse the process. There are many different hash functions, each with its own strengths and weaknesses. Some commonly used ones include MD5, SHA-1, and SHA-256. SHA-256, for example, produces a 256-bit hash value represented as a string of 64 hexadecimal characters. This fixed-size output makes hash functions very efficient for data comparison and integrity verification. Section 3. Data integrity, ensuring trust in a connected world. In a world saturated with data, ensuring the integrity of information is paramount. Data integrity means ensuring that data remains unchanged from its original form. Hash functions play a vital role in guaranteeing this integrity. Even a tiny change in the input will result in a drastically different hash value. By generating a hash of the data at the source and verifying it at the destination, we can ensure that the information has not been compromised. Imagine downloading a software update. The developer provides a hash value alongside the download link. After downloading, you generate the hash value of the file. If it matches the provided hash, the software is legitimate. This principle extends to various applications, from verifying backups to ensuring the authenticity of digital evidence. Hash functions form a cornerstone of data integrity in the digital age. Section 4. Digital signatures. Your identity's digital fingerprint. In the physical world, we use signatures to verify our identity and authenticate documents. Digital signatures serve the same purpose in the digital realm. Hash functions are essential components of digital signatures. A digital signature works by creating a unique fingerprint of a message or document using cryptography and hash functions. The sender encrypts the hash value with their private key and sends it along with the document. The recipient uses the sender's public key to decrypt the hash value and generates their own hash of the received document. If the decrypted hash matches the generated hash, it confirms the document's authenticity and integrity. Digital signatures are widely used in email security, software distribution, and financial transactions. Section 5. Password security, protecting your digital keys. In today's digital world, passwords are the keys to our online kingdoms. Storing passwords in plain text is like leaving your house keys under the mat. Instead, responsible systems use hash functions to protect them. When you create an account, the system generates a hash of your password and stores that hash value. When you log in, the system calculates the hash of the password you entered and compares it to the stored hash. If the two hashes match, you are granted access. To further enhance security, systems employ additional measures like salting, adding a random string of characters to each password before hashing. By combining hash functions with other security practices, we can protect our digital keys and safeguard our online accounts. Section 6. Message authentication codes, verifying message integrity. Imagine sending a message to your bank. How can the bank be sure it's really from you? This is where message authentication codes, or MACs, come into play. MACs are like digital fingerprints attached to messages, ensuring the message's integrity and authenticity. The sender uses a shared secret key and a hash function to generate a unique MAC for the message. This MAC is attached to the message and sent to the recipient. The recipient uses the same shared secret key and hash function to generate their own MAC of the received message. If the two MACs match, it confirms the message's integrity and authenticity. Section 7. Certificate fingerprints, authenticating digital identities. In the physical world, we rely on passports and driver's licenses to prove our identity. In the digital realm, digital certificates serve a similar purpose. Certificate fingerprints, generated using hash functions, ensure the authenticity of these digital identities. A digital certificate is like a digital passport issued by a trusted certificate authority, or CA. To verify a certificate's authenticity, a certificate fingerprint is generated using a hash function. The certificate fingerprint is a short, unique representation of the entire certificate. If you want to ensure that you are communicating with a legitimate website, you can check the website's certificate fingerprint against the fingerprint published by the CA. Certificate fingerprints provide a simple yet effective way to verify the authenticity of digital certificates. Section 8. The power of one-way. Why hash functions matter. Hash functions underpin a wide range of security mechanisms, making them indispensable for securing our digital lives. The one-way nature of hash functions means that it's easy to generate a hash from an input, but computationally infeasible to reverse the process. They allow us to create digital fingerprints, verify data integrity, authenticate identities, and protect sensitive information. Imagine a world without hash functions. Passwords would be stored in plain text, making them easy targets for attackers. Digital signatures would be unreliable, and data integrity would be constantly at risk. Hash functions provide the foundation for trust in the digital age. They are the invisible guardians, working silently in the background to secure our online transactions and protect our data. Section 9. The future of security, hashing's enduring role. As technology evolves, so do the threats to network security. Yet hash functions remain a steadfast pillar of security. The future of security will involve new cryptographic algorithms and security protocols. However, the principles underpinning hash functions will continue to be essential for securing information. Whether it's securing data in the cloud or protecting blockchain transactions, hash functions will remain crucial. The cryptographic community is constantly working on developing new and improved hash functions to counter emerging threats. The future of security is about evolving alongside hash functions to build a more secure digital future. Section 10. Conclusion. Navigating the digital world with confidence. Network security is no longer a luxury, but a necessity. Hash functions are powerful tools that underpin a wide range of security applications. From ensuring data integrity to authenticating digital identities, hash functions play a vital role in securing our digital interactions. By understanding the fundamental principles of hash functions, we empower ourselves to navigate the digital world with greater confidence and security. Hash functions are essential components of the digital infrastructure that underpins our modern lives.